This meeting's being recorded, guys.
Really? I'll trim it down as well. Do, do, slideshow. Oh, wait. Wait 1 second.
All right. So the effects of
Oh, wait,
corrosion
wait, wait,
and
Joe.
environmental
Just chill, just
damage.
chill, chill. Just chill.
All right, we ready?
Wait. Okay, there we go.
All right. The effects of corrosion on the environment and coastal infrastructure. So starting off, we have corrosion problems. So corrosion affects. So corrosion affects all types of infrastructure and is an issue with ships. It must deal with any sea or any building on the coast, which it comes with a heavy cost and must be dealt with by any one of those ships or buildings on the coast. So one of the most common forms of corrosion is rust, which happens when it's exposed to oxygen. So at sea, that's pretty much always. This happens because iron accepts too many electrons, causing rust to occur, and it weakens the iron, which means that it would have to be replaced. A small solution for this would be to have another metal put with the iron, uh, which creates, which it would be a cathode and it would accept the more electrons, and the iron would be an anode in which it would not accept as many electrons, which means that it'd be less likely to rust.
All right, the environmental effects of corrosion. Coastlines are an important natural resource due to the immediate access to the oceans, which allow for easy and efficient transportation of goods and materials, and the ability for fishing vessels to have access to further fishing offshore. Due to this, many coastal structures, primarily made of iron, are constructed along coastlines to maintain the industries that depend on reliable access to the ocean. Without protection or faulty protective measures, these structures tend to corrode quite quickly, and they do tend to release large amount of iron oxide when they do corrode. Depending on the function of these structures as well, they may also pollute the water directly or end up polluting the land of the coastline itself, either through direct deposition of pollutants or through the corrosion of the structure, which increase as you get closer to the coast. Heavy metals tend to be a very common pollutant in soils, and when the water erodes the land, the heavy metals end up getting introduced into the ocean environment. The implications of introducing all these hazardous materials are pretty severe. A buildup of iron oxides catalyze extreme algae growth, leading to harmful algae blooms. Algae blooms significantly decrease available oxygen in the water, block light from reaching below the surface, and release many toxins. The most common being microcystin, which is known for being fatal not just to marine life, but also terrestrial organisms as well. An increase of heavy metals in the ocean also causes severe heavy metal poisoning. The most common heavy metals that are prevalent in soil and water pollution are cadmium, arsenic, lead, and mercury. They are very neurotoxic and can quickly cause death in aquatic animals and can disrupt the food chain. In order to prevent these ecological disasters, you can either try to prevent the corrosion from happening directly. If that's not possible, barriers between the water such as seawalls and revetments can be used to prevent erosion can also be effective.
So I'll be discussing building codes and how the corrosive nature of water affects them. Um, so when you're building foundations, it is important to use the proper structural metal below the design flood elevation for when they're exposed to seawater or salt water. And note that freeboard is an added margin of safety in addition to the base flood elevation, and both combine to form the design flood elevation. And hot dipped galvanized steel is when you take normal steel and dip it into molten zinc, providing a protective coating for the steel. And this comes from the fact that the zinc will become anodic, meaning it will rust before the steel. Stainless steel is an alloy of iron and other metals like chromium and nickel to create a rust-resistant metal. And note that structures must use deep pile foundations to minimize the effect of erosion from fast-moving waters. And having a much deeper foundation under the houses along the coast provides extra stability so that the house maintains its structural integrity even when there is soil movement or disturbance from water flow. And corrosion-resistant coatings may include paints, powders, or chemical coatings applied to the metal to prevent oxidation and rust. For example, epoxy or polymer-based paints create a waterproof seal that prevents salt water from contacting the metal. And some requirements for equipment and exterior add-ons. So utilities and critical equipment must be placed above the base flood elevation, such as HVAC, electrical systems, and fuel tanks, or anything of critical importance. In addition, components must have a corrosive resistant protectant to prevent rust, and fuel lines must also include automatic shutoff valves to prevent fuel leaks in the event of flood. And joints on fuel lines can get rusted over time, so it's important to maintain them periodically in addition to coating them with a corrosion-resistant protectant. And also, decks and patios must be structurally independent because, like fuel lines, the connectors between buildings and decks can rust. In the case of flooding, this can be dangerous if the connectors snap and the deck separates, at which point it could wash away into other structures and cause more damage. And bulkheads and seawalls shouldn't be connected to any buildings or structures. If they are, the water that makes contact with them when the waves wash in will cause unnecessary strain on the structure and weaken it over time. And breakaway walls must be used with a non-corrosive metal because they're designed to break away when under enough pressure from water, allowing it to go through without breaking the central portions of the structure, like concrete supports. However, if these become corroded onto the supports, it will be much harder for them to break away from the building, and that can lead to structural damage.
Okay, now we're talking about the shipbuilding standards, a lot about the design and reparations that are in place to prevent stuff like that. So some standards that are implemented to combat corrosion. They have some protective coatings, as was mentioned earlier, that paint that water seals to prevent rust and water really from getting into or making contact with the metals on the hulls of the ship, creating rust to weakening the hull. So don't want that. And then still stay there. Then we have material choices. So metals like steel and aluminum and like weathered steels are very common upon ships because they're strong and take a little longer to rust compared to others. Some other smaller boats use fiberglass, which don't really go through that process. And again, excuse me, are considered required to meet the international standards. So protective coatings need the ISO 12944. The materials to prevent also pollution into the waters have to meet the ASTM A240 specifications. And some for cathode protection, they actually common practice that is being starting to be implemented is called passivation. Basically, when they kind of use like a dummy layer of metal to go under rust to prevent the behind layer of metal that is more important to the stability and structural integrity of the boat. And so important things to consider when designing and for maintenance. When designing boats, is important to consider the accessibility of all parts of the boat. So to be able to detect rust, it means not having a lot of tight spots, a lot of crevices and drainage blocks. Again, to prevent unidentifiable rust and weak points in the ship, along with proper labeling and compliance with maintenance standards. Here are our resources and continued, and that's it for now. Thanks. W.